So let's start. Welcome to our webcast series, Digital Twin Expert Talks. My name is Mike Billmann. I'm Managing Director of the IDTA. Today we have Birgit Bosch with us. Birgit Bosch will give us an introduction to the AAS Metamodel. Birgit Bosch is from Bosch Connected Industry. She's member of the board of the Industrial Digital Twin Association, so she's also a founding member. And we can say she's the lead architect of the AAS Metamodel. So she's also chair of the working group Open Technology in the IDTA. She's chair of the joint working group Asset Administration Shell with the platform Industry 4.0. And she has several more roles. It would take too long to mention all the roles she has. So she's really a technical expert for the Asset Administration Shell, and she will use the next 20 minutes to give us an introduction, a deep dive into the technology. Our today's webcast will be recorded and published afterwards on YouTube. That's it from my side.
Thank you very much for the introduction. Yes. So I will share my slides now. So it's as Mike just said, today we are really getting into the meta model. So this is really an expert talk. So it's for really understanding the information model behind the asset administration shell. And so what it is about, so we all, or it's assumed that you know a little bit about the asset administration shell, otherwise it's probably very hard to follow. So on the left side, you see the concept of the asset administration shell with its submodels, with the properties and so on. And then we do have the specification, and the specification is a basis for interoperability in the end. And this is the document I will explain in this expert talk today. If you have questions, you can put them into the chat, and later I will try to answer all of your questions. So I already said it, so you should have an idea that why to build digital twin, what they are good for, and why you need them for your domain. So I will not give a motivation or something like this. So I think these are other expert talks. There were already two, and they gave a very good insight why you need digital twins, and also why do you need a standardized and interoperable digital twin, the asset administration shell. So you should have a little bit an idea what the asset administration shell is about. It's also helpful if you have a little bit of know-how in UML and can read a UML diagram. I will explain it, but that would be helpful as well. And so, yeah, so you are here in the right session if you really want to learn about the meta model. And if you are a security expert, so I'm sorry to say that security, the security part will not be part of this expert talk. This would be another expert talk, because there is also a lot, of course, to say about security in the context of digital twins and the asset administration shell. Okay, then get started. So the first thing, if you want to start implementing an asset administration shell, is to download the specification itself. And here just the links. That's it. Then, if you are even familiar with UML or have an UML tool yourself, you might also be interested to import the model and to play around a little bit. There is, here you see our GitHub repository. There you also find the specifications, and including the XML format that is supported by most UML tools. So you might want to import it if you want. What is important for those of you who already perhaps know the version 1.0 or 2.0 or another one, is that there is also in the annex, and that's why I really have it at the beginning, because if you're really a programmer and develop asset administration shells or asset administration shell tooling, you would like to know what changed, and there is this annex. And there are also other screencasts, and in these other screencasts, the differences will also be explained. Today, I will not focus on the differences, but on the basis. Yeah, and then of course, what I said, another annex you should also have a look at before reading the specification is how it is done, how is it written down, and perhaps if you need get re-familiar with UML and how which kind of modeling, because of course there are always modeling styles, which modeling style is used in this specification. And this is how the complete specification is built. Every chapter is starting with a diagram, and then there is a table like this explaining the diagram. So it's explaining all the attributes and the types, giving an explanation, and of course the cardinality. And additionally, we also, in some cases, we do have constraints that need to be fulfilled. So that's the starting point. And now, yeah, it's still not the core of the asset administration shell meta model, but yeah, or this is, so what is the goal of this expert talk is that you can read this diagram and not only read it, but understand it, have a little bit of background, know how, why is it like this, and what do you need to know when implementing this. And so if you are familiar with the asset administration shell and have a little bit and also a little bit familiar with UML, it's quite easy to read. So you have the asset administration shell. The asset administration shell is consisting of submodels, and a submodel again is consisting out of submodel elements. So that's very easy. One thing you already see on this diagram is that this is a shared aggregation. So the submodel is an object, a standalone object, whereas a submodel element is just existing in the context of a submodel. And in this case, this kind of presentation is chosen. And this is a dependency arrow, just saying this is a type submodel element, and then you have to look up this corresponding class submodel element. Then we do have a lot of different submodel elements. In this diagram, only one of these is shown, the property. And what is also shown here is that a submodel as well as a submodel element can have a qualifier. I will explain it later what this means and what you can do with it. And perhaps the most important thing with digital twins, what is a digital twin? A digital twin is a representation of an asset. And here you have the information about the asset itself. And we distinguish between asset types and asset instances, so product type and product instances. And what is very important is that we do have an identifier for the asset. It's a global asset ID. And we also support some additional asset IDs I will explain later. And then what we also do have are so-called concept descriptions, because for the asset administration shell, semantics is very important. And so this is conformant to the IEC 61360, we allow also to specify the semantics of properties. So this is the overview. And now I will go through the model and explain the most important aspects and what you should know about the meta model. But before coming to the main classes like asset administration shell, submodel, and so on, perhaps you already had a look when you see at this diagram, you see there are a lot of different classes that are inherited. So this is how it is displayed in Enterprise Architect, but in other tools it might be displayed in a different way. So this is not important for the meta model, but all of these classes, so these 5 classes are inherited by the submodel. And you see here, same classes has semantics, for example. I explained semantics is very important for the asset administration shell. So this is by inheriting the abstract class has semantics. And so all of these attributes that are inherited is part of the common attribute section. So these are the attributes that are reused by a lot of different classes and are also extremely important to understand how the complete model is used in the end. Okay, then we start with two terms, referable and identifiable. So identifiable, here you see it, it's like in a passport, that's really an identifier. And so identifiable is really if you have a globally unique ID, whereas a referable is just unique in the context of an identifiable. So it might be structured, but in the end, it's always an identifiable. You need, as I said, the submodel elements are part of the submodel. They are not existing in their own, but nevertheless, they are referable because they have an ID short. That's the most important attribute here. They have a name, an ID short. An identifiable has an ID. It's only optional for an identifiable to also have an ID short. Then, of course, we have descriptions and display names and so on. But the main attribute is ID short and ID. So this is really important to understand when also talking about referencing and reusing stuff. Then, and I think this is really now the core, the heart of the asset administration is how to deal with semantics. Perhaps I explain first this figure that's well known out of other representations on the asset administration shell. So here we have a property with a value 2000, and then of course, what does it mean? 2000 year, euro, steps, whatever. And here you need the semantic ID, and the semantic ID, in this case, it's an E-class property. It has, again, a unique ID, and that's it. And then, but it has a definition. What does it mean? This definition is also provided in several languages. And very important, it has a unit, a physical unit you need to know, and it also has a data type. So after now resolving this semantic ID, you know, okay, it's the maximum rotation speed of the corresponding product. And this is exactly what is done here. You have a semantic ID, and this is exactly a globally unique identifier explaining the semantics of the element. We also support some additional semantic IDs because there is not only one dictionary, and sometimes there is also some relationships between different semantic concepts, but the main semantic ID is only this one. It's exactly one, and this is used for matching and all kind of how to deal with semantics in the asset administration shell. So this is just optional, that you can also add supplemental semantic IDs. The semantic ID itself is also optional, but really it's really recommended to use it. And it's also done like this because we also have in mind that the asset administration shell is built, and at the beginning of engineering an asset administration shell, you might not yet have all the information you need, and that's why some attributes are optional. Also, we strongly recommend that it has a semantic ID, for example, in this case, at the end. Another one, I promised that I also explain qualifiers. So some of the elements, submodels, are qualifiable, we are saying, or also a submodel element is qualifiable. And this means you can add additional qualifications to an element. And here again, you see in this case, it's the IC/CDD dictionary, and they are standardizing several different qualifiers. One of them is a lifecycle qualifier, or the lifecycle type it's called. And so one qualifier would be, for example, for a submodel for a bill of material, that this is the build as built. So if you have a look at this dictionary, you will see that this, again, the semantic ID of this qualifier has exactly this semantic. It's a lifecycle qualifier, and the value is built. It has a lot of other values, planned, built, whatever. and also the values itself may have a unique ID. This is what is done also here, because all of this is standardized in the corresponding dictionaries, or we could also do it with our concept descriptions. So this is how to use qualifier. And we also distinguish value, concept, and template qualifier, but for today, I think it's going too much into detail. So here I would like to refer to the specification for more details, but that's the main thing to understand when dealing with qualifiers. Another important concept is the has data specification. It's more an option for extensibility of the specification. We have predefined data specifications, especially for concept descriptions. We don't have any others up to now. So the only thing you need to understand is, in a way, the standardized data specifications we have so far. And that's exactly the one for concept descriptions conformant to IEC 61360. I will come to this later. So this is just an extension point the meta model provides, but again, for predefined and standardized extensions. Has kind, I already explained the asset kind, so type and instance, but this shouldn't be mixed up with a modeling kind. And we distinguish here between the instances. So these are real digital twins with values, but also to really be interoperable, you of course need to define how such a submodel is looking like, and that's a template. And if you go to the IDTA, the Industrial Digital Twin Association, you will find a list, in the content tab, you will find all the registered submodel templates. So for MTP, for documentation, for the digital nameplate, and all of this. And these are templates, but they are modeled with the same meta model. You will also find them in a GitHub repository. It's very, very important, because one thing is to be interoperable with the asset administration shell, but if we do not have standardized submodel templates, the interoperability is of course also not really given. Okay, then we do have references. So we distinguish between external references, for example, to a dictionary like eClass, ICCDD, or to an asset, a global asset ID, something like this. But we can also reference elements within the same asset administration shell or another one. And so we can really directly, for example, make a reference between a capability and, for example, an operation. So it's a reference to an element of an asset administration shell. We call it model reference. So this is referencing is probably a chapter you need to look into twice to really understand it. It's not, there's also, I also have some examples with me. We also have a text serialization of this. And so we have several examples here for global and for model references. But just remember, global reference is something outside. Model reference is something when you reference something from an asset administration shell. Another one, another submodel. For example, if you have a bill of material, you might want to reference in another asset in another asset administration shell. Okay. So these were the abstract classes. So it's probably difficult to understand because they are all introduced to now make the real model understandable and using the same terminology and the same attributes. And now here again, we have, this is the asset administration shell, the meta model of it. And we do have the asset information, as I said, with the asset kind, product type or product instance, a global asset ID, very important. Here again, it's only optional because at the beginning you might not yet have it, but at the end, you need to have a global asset ID because otherwise you cannot find it in a registry or something. So you wouldn't be able to find or answer the question, is there an asset administration shell available for my asset? And this is one of the important questions. Of course, we also allow other queries here with specific asset IDs. For example, if you do have a specific customer part ID of your product, you can search for it. But you might find, because they are typically not globally unique, you might find more than one asset administration shell for it, at least if it's a registry with more than one company in it. It depends. But this is the global meta model, assumes there might be several asset administration shells for an asset, and it's not, it's only if it's globally unique, you can make a direct link between the asset and the asset administration shell. And then, of course, it has several submodels. And this is now the submodel. This is from the figure from the very beginning. So, for example, technical data and a submodel would have maximum rotation speed, a value, the physical unit, and so on. And this is exactly what we have here, but it's now more important to have a look at which kind of submodel elements we are supporting. I already look at the time, so I need to be a little bit faster. So there are a lot of different submodel elements. So here is a complete list of all the elements. Property I already explained, but there are also relationships, very important, files, blobs, operations, events, and also very important collections and lists. Okay, that is now a difference between collection and list. A list is a set, whereas a collection is more something like a record or struct or whatever. As you see, this is here the elements within. For example, here we have 3 properties, all have a different semantics. This is a mother, this is a father, this is a son, whereas here we would have a list with all the members. So it's a different kind of modeling and a different semantics between collections and lists. I mentioned this because it's new that we really distinguish between collections and lists. In former versions, we just have had collections. Due to time, I cannot go into detail here. This is just an example how to use the asset administration shell for composite assets, so for complex assets consisting out of others. I already mentioned the bill of material, and you can model it using the elements of the asset administration shell. And this is, I already explained it, so that we support concept descriptions conforming to IEC 61360, and this is exactly what is here. If you look into E-class or ICCDD, you will see these are exactly these attributes that you will also find there. Yeah. What I always recommend when wanting to learn the meta model is the best way to learn the meta model is to use the AASX Package Explorer and to just try to model something yourself, some submodel you have in mind, some properties, and then it's a very, very easy and a good way to learn how to use the asset administration shell and to also learn the meta model behind. And what is also important, we do have a lot of different serializations available for the asset administration shell, Automation ML, JSON, XML, OPC-UA, RDF. And for all of these, for XML, JSON, and RDF, you will find it here in the GitHub. For OPC-UA, it's maintained by the OPC-UA Foundation and similar with the Automation ML. So we have several collaborations for really supporting all these serializations. The mapping rules are to be found, how to do it from UML to the corresponding serialization format are found in the GitHub repository. And here it's a Eclipse data, Eclipse project, a top-level project, Eclipse Digital Twin. Please have a look here. So here you really will find a lot of open source support for building your own asset administration shell, your first digital twin. And yeah, so just use it and have a look at it and also follow it because we are just starting. There are a lot more open source projects. Yeah, and now, we could go into the question sessions.
Thank you, Birgit. Are there any questions? Please just raise your hand or put your question into the chat window.
Or some of your questions might also be answered. That was not my last slide in this questions and answer sections, but this is also a way to question if you don't have it now, but later. This is also a very good source for this.
Just one question. Sebastian Braun is asking, how are AAS implementations validated? Do you provide validation tools?
Also yes and no in a way. Of course, XML validators there are, and also existing tools, but then of course it's just the schemas. But what we are doing in the Industrial Digital Twin Association, we have a working group working exactly on this, so on certification, validation, so that in the end we can really say, yes, this solution, this implementation is conform to the specification or not. It's not yet available. We are working on this, but it will be available quite soon.
Yeah. Just last week I saw a prototype of the testing environment, so it's going to be available soon.
Yes.
Our next webcast will be not in 2 weeks because we're going to be on the SPS show. So if you are there, please come by. The next webcast will be on the 17th of November, so 1 week after the SPS show. And we have Andreas Oselski from Phoenix Contact, and he will introduce us to the AAS REST API, accessing the digital twin. So another tech talk on the topic of AAS.
Yes.
Thank you for
don't miss it.
Don't miss it. Thank you for today. If you have any questions, there was one question about the slides. Please just contact me. I will provide you all the information you need. Thank you so much, and see you in 3 weeks or on the SPS show. Thank you, Birgit.
Thank you. Bye-bye.
Bye-bye.